Okay, I had a question about this particular homework problem where you're asked to try to figure out if there is evidence of a relationship between age group and type of communication preferred. And so this is really going to be an extension of the chi-square test that we did before. So um, remember that with a chi-square test, you're basically just comparing some kind of observed distribution to what you would expect. And so in all cases, your chi-square statistic is going to be the sum of all of these differences. So you're going to be taking the observed minus the expected and then squaring it, dividing it by the expected, and then adding them all up. So in this case, we would have, we've got 5 and 2 here, so we would have five terms that we would be adding up. Okay, so that's the basic idea of a chi-square test. Your chi-square statistic is calculated this way. Now, the example that I gave you in the lecture only had two groups and two possible classes. So we had males versus females as for columns, for rows, and then we had left versus right for columns. So we really only had these 4 cells. Okay, so what we're going to see with this problem is we have more than 2 rows. We actually have 4 rows, and we have more than 2 columns. We have 4 columns. So we're going to actually have 16 different cells that we're going to have to compare the observed and the expected, and then add them all up for the chi-square statistic. Okay, so let's go ahead and take a look at the actual problem then. So I've clicked on there and I've downloaded the data and I pasted it into Excel. And this Excel sheet is also available to you, so you can use it for reference. So what they had here were the 4 different generations here in this column, and their stated preference for group meetings, face-to-face meetings, emails, and other. Okay, so what we're given is that these were the observed frequencies. So really the only thing that came down in the download is just this data here. So I've created this table where I've added up all the sums and found out that sure enough there were 500 people in each generation that were sampled. Okay, so we've got stratified sampling here. And then over here I've added up all of the the number of people who said they preferred group meetings, face-to-face meetings, emails, and other. Okay, so the reason I needed these numbers down here was so that I could calculate what would be the expected value. So the expected proportion, so the idea would be that if in general 800 out of 2,000 people prefer group meetings, then that proportion would be the same for all generations if there were no relationship between generation and preference. Okay, so and likewise down here, if in general 850 out of 2,000 people prefer face-to-face meetings, then that would be true for all generations. Okay, so what I had to do was figure out this proportion, this general proportion, and I put that here in the green. I've just taken, so here I took 800 and divided it by 2,000. Okay, so these are the proportions for each different type of communication. Okay, so once I have these, this lets me figure out, well, what would be my expected number. Okay, so you see that all of these rows turn out to be the same because what I did here was, okay, so in generation Y, there were 500 people, and so if there were no relationship, which there is in the null hypothesis, there's no relationship. If there were no relationship between the generation and the preference, then simply 0.4 of 500 would be in this cell. Okay, so I multiplied cell B9, which is 500. B9, which is 0.4 times the sample size, which is 500. Okay, so these are my observed frequencies up here. Okay, and notice that in blue I marked the 16 cells. And then in this table, I've got the expected. Okay, so these were calculated based on the overall proportions. Okay, so what I need to do then for all 16 of these cells is to calculate the difference between the observed, that is here in blue, minus the expected, and then we square that difference and then divide by the expected. And I think I have a mistake here, so it should be over expected here. Okay, so once I've got my observed table and my expected table, then I can calculate those. So you see, this is what this is in cell B21 here. I've got observed minus expected squared over expected. Okay, so I did that for all 16 cells. So just made that term for all 16, and then I added them all up. So basically, this is a grand sum. This is the sum of observed minus expected squared over expected for all of those 16 cells. Okay, so that's a big sum. Okay, so now where do we go from there? So we've got this chi-square. This is our chi-square statistic, and the problem does ask you to put that in, but now we need to be able to figure out what is the p-value, what's the critical value, and all that, so that we can do the actual hypothesis test. Now, one thing that I didn't emphasize in the lecture before was how you actually find the degrees of freedom for an independence test like this. Now, in our case, we had 2 rows and 2 columns, and so we just had 1 degree of freedom. Now, the reason for that was because you calculate your degrees of freedom in a chi-square test as rows minus 1 times columns minus 1. Okay, so in this case, we don't have 2 minus 1 times 2 minus 1, which is just 1 anymore. We have rows is 4, columns is 4, so we have 3 times 3. We've got 9 degrees of freedom. Okay, so when we calculate our p-value, we have to put in now remember, because we're interested in the right tail, and let me see, I had a slide about that. So we want to know the area of the we're interested in over here, the amount of area over here. So we're going to do 1 minus, we're going to put in our observed statistic, and then do 1 minus that. Well, I'll show you what I mean. So here we're doing 1 minus chi-square distribution, and then this is the x value that I had. So this is this 105, and then B28 is my degrees of freedom, and then I do true. Okay, and then what we see here is that it's 0. If we were to make this scientific notation, let me see if I can do that real quick. Scientific. Okay, we see that yeah, it's 0 going out very many decimal places, and the reason for that is because if you look at the size of the cells, this is a pretty huge difference here, and you can see that the reason for that is because generation Y only said other 5, so the difference between that and that is quite large. So consequently, the chi-square statistic was very large. This is a very large chi-square statistic. Notice that I went ahead and put the critical value in this spreadsheet here also for you, just to show you. So, and I used the chi-square inverse for this, and they asked us to do a 0.01 alpha level, so 99% confidence with 9 degrees of freedom. We only needed to have a chi-square statistic of something larger than 21 to be significant at the 1% level. So, and we have something much larger than that. Okay, so we can definitely reject the null hypothesis that there's no relationship between generation and preferred type of communication. Now, so this is how I did it, and this is a good way to understand what exactly the chi-square test is doing. But for those of you who got the real statistics add-in, let me show you. They cut out a lot of steps for you and give you kind of a nice shortcut. Let me see if I can find it again. So you go to add-ins, and now one of the maddening things about this is that it keeps uninstalling. So if you find that your real stats add-in is missing, then I found that if you just come here and uninstall it, and then you come back in here and reinstall it, then it magically reappears. I'm not sure what's going on there, but that happens. Okay, so if you come back here to their plugin and you come down here to the miscellaneous tab, you'll see that there's a nice little chi-square test for independence option there. Our data analysis tool pack doesn't have that, but this does. So let's go ahead and see what this will do for us. So we'll select there. Okay, our input range, I'm going to click there and then select these. I'm gonna make sure I get all 16 cells plus the row and column names. The alpha that they asked for is actually 0.01, right? And yeah, so the headings are included with the data. And let's see, I'm going to say, okay, just whatever output they produce, put over here. Okay, and let's see what that does. Okay, so notice that the first thing it does is it generates this table of expected values, which is identical to the table that I made over here. So that just kind of does that automatically, because that is, a necessary intermediate step to getting your chi-square statistic. Okay, and so over here it shows you, okay, so now it's conducting the hypothesis test. It's, naming its alpha here, and it shows you its calculation of degrees of freedom here, which is 4 rows and 4 columns. That's rows minus 1 times columns minus 1. So degrees of freedom was 9. And it showed you this Pearson's here. This is the chi-square statistic that I calculated, which is down here. Okay, so they got the same number, and then so they show actually the p-value. It goes out 18 zeros. Okay, so it's really tiny. And they also give you the critical value here, which is 21.6, which is what I had down here also. Okay, so I mean, if like me, you kind of like to see how these things are calculated, and you can go ahead and make this, but you have to remember that a key step here is to create this expected table based on the overall proportions for each category. Okay, and so you make this expected table, then you can do the chi-square statistic by adding up all the square differences divided by the expected values. Okay, and then you have to do this. One key thing to remember for the p-values, you have to do one in Excel. You have to do 1 minus chi-square. Okay, the dist, and then of course we always have true here. Okay, now just coming back to the to the actual question. I think that was probably the key difficulty. So just remember that the null hypothesis for a chi-square is that your null is that there's no relationship between these two categories. Okay, which means that your alternative is that there is a relationship between these two categories. Okay, and then it just asks you to put in the chi-square statistic, which is this thing. And then you just have to go on and do the conclusion. Okay, all right. I hope that helps clarify any problems that you had there.